Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P0967 refers to the CVT-driven pulley pressure control valve circuit high issue in the Honda HR-V, manufactured between 2016 and 2022. This DTC indicates a problem with the electrical circuit of the continuous variable transmission, CVT, driven pulley pressure control valve. It's essential to understand that such an issue cannot arise from mechanical problems within the transmission itself. The pressure control valve is crucial for regulating fluid pressure in the CVT, affecting its efficiency and performance. If this circuit experiences high voltage, it can lead to improper functioning of the transmission system. Each troubleshooting step must be carefully conducted to pinpoint the exact cause of this error. DTC P0967 refers specifically to an issue within the CVT-driven pulley pressure control valve circuit, indicating that the electrical parameters are out of the specified range. The CVT pressure control valve is located near the transmission assembly and plays a critical role in fluid management, helping to maintain the correct pressure for seamless operation. This valve regulates the hydraulic pressure that controls the driven pulley, ensuring that the vehicle accelerates smoothly and efficiently. A fault in this mechanism can affect shifting performance, fuel efficiency, and ultimately driving safety. Understanding where this component is situated allows technicians to effectively diagnose the issue during troubleshooting. The possible causes of DTC P0967 primarily involve electrical circuit issues. A short circuit can occur in the wiring between the CVT pressure control valve and the power control module, PCM, leading to erroneous readings. Poor connections or loose terminals can also trigger this code by preventing the necessary voltage or signal from reaching the solenoid properly. Another potential cause could be a malfunctioning solenoid valve, which would not respond correctly to the signals sent from the PCM, thus creating inefficiencies. These factors contribute to the high circuit voltage reading recorded by the onboard diagnostic system, prompting the need for further investigation and repair. When experiencing DTC P0967, drivers may notice erratic behavior from the transmission, such as delayed or harsh shifting. Increased fuel consumption can also occur, as the CVT may struggle to find the correct gear ratios. The presence of the check engine light serves as the initial indicator that something is amiss within the vehicle's systems. Additionally, if the CVT cannot regulate pressure effectively, it can lead to overheating or potential failure of the transmission over time. Recognizing these symptoms promptly enables drivers to seek repairs before more severe issues arise, leading to costly repairs and extended downtime. In the first troubleshooting step for DTC P0967, it begins by setting the vehicle to the on mode without starting the engine. This process is essential for establishing initial communication with the onboard diagnostic system. Next, the technician will clear the DTC using the Honda Diagnostic System, HDS. Subsequently, starting the engine and allowing it to run for at least 1 second is crucial to observe whether the DTC reappears. The technician must check for both pending and confirmed DTCs using the HDS, as this provides insights into whether the error is persistent or intermittent. If DTC P0967 is confirmed, it indicates a recurring problem that requires further investigation. The second step involves determining the potential area of failure by testing the CVT-driven pulley pressure control solenoid valve. This valve is pivotal in controlling the hydraulic pressure essential for optimal CVT performance. By conducting specific tests on the valve, one can ascertain its operational status. If the solenoid valve is functional, the next steps can proceed to investigate wiring and connections. However, if the solenoid valve is determined to be faulty, it may necessitate replacement, marking a definitive point for resolving this DTC. Identifying a successful function here allows for more focused troubleshooting on the wiring and connections. In this third step of troubleshooting, the technician will investigate the wiring for potential shorts. After turning the vehicle to the off position, the technician will proceed to jump the SCS line using the HDS. The solenoid wire harness must then be disconnected along with the PCM connector. With the vehicle set back to the on mode, voltage testing between specified test points provides crucial data. Test point 1 is located at the solenoid wiring, while test point 2 is connected to the body ground. A voltage reading at these points indicates a short to power, necessitating repairs in the wiring leading to the PCM. This systematic approach to checking voltages helps pinpoint electrical faults affecting the DTC. Step 4 focuses on examining the wiring for shorts to ground. The vehicle should remain in the off position while ensuring the solenoid wire harness and PCM connectors are still disconnected. Continuity is tested between designated points to check if any wiring issues exist. If continuity is detected, it suggests a short to ground, necessitating repair of the DNLS wire. Conversely, if no continuity is found, it indicates that the wiring itself is intact. In such a case, updating the PCM software or replacing the PCM might resolve the DTC P0967 issue. This step is crucial to ensuring that all wiring conditions are correct before moving on to replace any components. The final step investigates the condition of the CVT-driven pulley pressure control solenoid valve. Initially, the technician will remove the valve body assembly for a detailed inspection. Measurement of resistance across specified terminals provides insight into the solenoid's performance. Resistance readings should fall between 4.6 and 6.3 ohms. If the resistance is within range, the solenoid is operational, prompting a check of the solenoid wire harness for potential damage. However, if the resistance fails to meet these specifications, it indicates a faulty solenoid, necessitating the replacement of the entire valve body assembly. This step is critical to ensure that the transmission fluid pressure can be properly regulated, thus maintaining overall vehicle performance. Upon completing repairs related to DTC P0967, the technician must perform final verification to ensure the issue has been rectified. This involves clearing the DTC again using the Honda Diagnostic System, HDS, to reset the vehicle's fault codes. Following this, a thorough test drive is essential to replicate real driving conditions, allowing the technician to monitor the transmission behavior. During the test drive, they should be attentive to any malfunction symptoms that may arise. If the DTC does not reappear and the vehicle operates smoothly, the repair is confirmed as successful. This step ensures the integrity of the entire repair process and helps to reassure the driver of vehicle reliability. In summary, addressing DTC P0967 in the Honda HR-V requires a systematic approach focused on the electrical circuit associated with the CVT-driven pulley pressure control valve. Initial steps emphasize verification and testing of the solenoid valve and wiring integrity. Ensuring each component functions correctly is crucial for maintaining optimal transmission performance and preventing further issues. Regular maintenance, including periodic checks of the electrical systems, can help avoid these types of faults in the future. Understanding the role of each component involved in this DTC allows technicians to ensure more efficient repairs and enhances vehicle reliability. Follow-up checks and test drives confirm the success of the repair, ultimately delivering peace of mind. Please like and subscribe to the channel. See you next time.